I may have been distracted. I don't remember a ding, but
Yeah.
go. Here's an oldie but a goodie. Back from the 2018 midterms.
We used to have midterms.
2018 midterm elections. No, because in class we were talking about just how terrible and constant the ads were, and they were showing up on everyone's YouTube feeds. So
your video would not show up on my computer. I had to use somebody else's computer.
they keep monkeying with the firewall. You know how a bunch of different sites and games keep getting blocked and then unblocked?
Yeah, no math games.
Okay.
No math games.
For some reason, it's hitting my YouTube channel too. There's times where it won't, you can't access my YouTube videos on your school laptop, but these other 5 people can. And it's just, they got a new firewall last spring, and then these new computers are trash, and the combination is no bueno. Ism?
Is this stuff for 4, 3, 5,
It was just, we did regression instead of...
I just tried to find it on the video and I couldn't.
Yesterday's video, we talked about it. It was just, remember that noect thing? You can use this to make noect. Initial amount. So it's
It's like a per.
Yeah, 2000 equals 125 EKT. You solve for K, now you got your model. It was super quick, but we just did it with regression anyway. So. Do the thing! You math now! Hi.
When will our next test? I got a 93.
It's Thursday or Friday?
Friday.
Oh yeah, you had yours on
Friday last week.
Friday.
So it'd be Friday this week.
No, it would be Monday.
No. I'll be gone. I don't want a Monday.
5 days, then quiz. That's how we do it.
I hate quizzes.
We review it right before you do it.
I know, but it's just a Monday. It's that.
Hi.
It's how much I will be gone with.
Quiz every Friday.
That's what I think.
They make us dread Friday.
Yeah, we should just do that.
No, but then we wouldn't have
homework for the weekends.
Exactly. Yeah, exactly. That's good.
Yeah.
No.
Right.
Do the problem.
Are we going to have a quiz for Tuesday before Thanksgiving break?
Probably.
It says, get 2 reasonable models. Say which one is more appropriate. Whichever more appropriate model you chose, answer the question at the bottom. Can everyone, particularly in the back, or those that are ocularly challenged, see everything up there?
Zoom in a little bit on the table.
I can...
That's perfect. Ideal.
Better?
Yep.
Okay. Save it there. What's up?
I just found the R&R script and
Look through your notes. Shut your noisemaker. Because we've done it a bunch of times. And you were supposed to write it down.
I'm in mode.
Just... I hope you're not doing this.
I'm not
Good job.
doing that.
Calculator. I don't know what that means.
Domain. It said error domain. If only we had 4 commandments of domain. If only there was something specifically about what you were trying to type there in which you broke something with domain. If only we looked at the stat plot before starting to press buttons to determine which models we should even try. Hint, hint. A lot of clicky, clicky, typey, typey still. We getting there, like in the groove, probably on our last model or so. Just got to answer the question. No, these ones are a little more involved. That's why there were only 2 for your homework. do about a minute to finish up. I'm going to assume we all know how to type stuff in and start getting the models, so I'm just going to start with that so we can get to the question part. Come on, you. How is there still thing over here? There we go. Okay, so we had, what was it, 0 and 1.5. Zero. And 1.5, 3.2. Okay. All right. So, y'all know the really annoying commercials. They're not even talking about policy. They're just like, this guy sucks. Vote for me instead. Okay. So this is from 2018, so it's 3 years ago now. Where we were just kind of talking about that in class, and we're talking about survey bias and that kind of stuff. Blah, blah, blah. Too many ads, people just going to say, screw it. Okay. Use the data to create two reasonable models and explain which is more appropriate. So you're looking at how many ads there are versus how many voters are just saying, fornicate it. So we had a bunch of data. Paul, how do I turn my stat diagnostics on? Mode something, because Lars told me so. Where on mode? Stat diagnostics. Okay. Or alternatively, if you are on an 84 plus and complain about it incessantly. Second, catalog, right above 0, down to the D's and diagnostics on. Okay, also works for the emulator that's on your laptop, because that's a TI-83. So now that I'm there, I got my data, I'm going to, before I go to stat calculate, I don't want to just start calculating stuff and throwing it on there, because I need to know what I should even be trying to calculate. I'm instead going to stat plot, turn plot 1 on, zoom to my stats, because then I get an idea of what type. And when I see that upward curve, I already know I can throw out linear, I can throw out logarithmic, because it curves the other way. But power, exponential, quadratic, and logistic are all still on the table. So real quick, I'm going to get all those. Stat, calculate, quadratic regression, store it. I'm assuming you all wrote down your R coefficients, so I'm just going to say is 98.66 3. Okay, stat, calculate. We said exponential. Was 95.97. Stat, calculate. Power. Ruh-roh. Can't do that. Why not? Well, you think about what power is. Power function. X to the b, and one of my data points is 0 as an x. I can't plug in 0 for x because I have that horizontal asymptote at y equals 0. So you can't do that. So that means power is already out. So I'm down to quadratic, exponential, and stat, calculate, logistic. Which will not give me a correlation coefficient, but I'll at least get a model. Absolutely random while Frank is thinking here. Especially the ladies in the room. How many times, or how frequent is it? Think about elementary school. Think about even right now, at home, with a teacher, with your parents. Are you told to stop fidgeting? Stop playing with your hair? Stop picking at your nails? Okay? Do you know that it's perfectly normal, right? Like, you're doing it because of A, either it's a stress response, or B, you're literally just looking for tactile input, and you're supposed to do it because that's what your body requires right now, what your brain requires. And it is purely social obligation garbage that says you can't. Just as I'm going around the room, I'm seeing how many of you, as you're going in the tank, are sitting here like playing with your hair or staring at your screen. How many of right now your foot or your knee is going a million miles an hour? Okay. It's normal. So, I've got all of that stuff. I'm going to go back to my graph. It's going to show me some stuff. We have our quadratic, was a 98% fit. We had our power function, or sorry, yeah, our power function, and our logistic. Now, I don't know about you, but just looking at them, I would say my logistic fits the best. If I had to choose between the quadratic and the power function on my screen between yellow and blue, which would you choose? I'd probably go with the quadratic as well because it had a higher correlation coefficient. And it literally just looks like it fits my data better. So for part 1, you should have.
Why can't you do cubic? It has a higher correlation.
Could I do cubic? Stat, calculate. I went completely the wrong direction. There we go. Cubic. I didn't even think of that. Okay. Yeah, I think it's safe to say that that power function's out. There's our logistic and then our cubic. I like that. That cubic looks pretty good. So, I think it's safe to say then that you should have your logistic model and I would say either your quadratic or your cubic. Okay. We should definitely have logistic. Like that hit almost perfectly. So we should definitely have that. The quadratic cubic, as long as you got a little bit reasoning with it. Which one would be more appropriate? Now we need to look at the context of the problem. I put this many ads on TV and YouTube. Okay, when I say TV, we understand in the year 2021 that includes YouTube and Hulu and Sling and Discovery Plus and, right? Okay. So I put this many ads on a thing, people stop caring because they're just sick of it. I should have logistic, I should have one of these polynomials. Which one is more appropriate? Well, what happens when I say, oh, I don't know, I'm going to put in 200 ads instead? And the most I can go to is 100% of voters not giving a rip. Like literally everyone just abstains. Like, nah, no, neither of you. What does it do to the graph? My power function, my quadratic, both go off into the wild blue yonder. It doesn't make sense to eventually say that 130% of people aren't going to care. It also doesn't make sense that eventually everyone votes 4 times. Like, I don't know what a negative would even be in this context. Okay. So, logistic would be the more appropriate model. Now, if I'm using that appropriate model, okay, let's go down to trace. There we go. So it'd be the 55.86 blah, blah, blah over 1 plus. Okay, so do you have the right model? Assuming there wasn't any fat finger syndrome going on. Happens to me all the time. You know the predictive text on your phone? I screw up so much that my predictive text is wrong. Like it suggests incorrect things. Yeah. So I would choose the logistic model. Make sure you got it written down correctly. So use your chosen model to predict the percent of disaffected voters after 125 ads. So I'm going to go to that model and I'm going to trace that out to 125 ads and say about 54.9%. But then it asks, how many ads until 60% don't care? How many? Like, look at my Y's. When am I going to hit 60? Why not? Because my natural limit to this was at 55.8. Okay. So we should have our logistic model, our quadratic, or our cubic. We should then choose logistic. 125 ads was about 54.9%. And after how many ads will 60%? Never. Because my limit was at 55 and change. So, do you have the logistic and a quadratic or cubic, meaning you didn't choose the power function, you couldn't choose exponential, you definitely didn't choose logarithmic because it wasn't possible. You answered the question. You answered the question. And then I'm going to, oh, and then explain which one is more appropriate. Did you have logistic because you can't go past 100% of people? Or something like that. Okay? Or percent can't be infinite. Or people can't be infinite. Or some sort of explanation to say it is more reasonable. Okay? There's your 5. A lot of calculator mojo. But once you have the calculator mojo, you got to know how to interpret it. There were only 2 problems. I don't remember anyone asking. Got anything? Because you had to do all of that. All right, then. Big kahuna.
Yeah, so relaxing.
This is what you need to know to move on to the next class. Everything that we did so far was an extension of Algebra 2. This is brand spanking new. The 12-year-old in me wants to say that's what she... No.
Do it.
Do it. I'll do it.
Everyone got one.
How long is this chapter?
Typically, it's about a 3-week-long unit. Most of our sections are 2 days. Okay? Most of our sections are 2 days. There's 8 sections there. 16 school days, 5 days in a school week. We're going to be in this one for a while, so don't freak out by, boy, that's a lot of paper. You know how this goes. Everyone in here is at an A or a B right now. Y'all doing great. Keep doing what you're doing. It's just, now you're going to, the first 3 sections are stuff that you should have covered in geometry. I know that you didn't. We're going to slow down through it, chill, relax. After that, it's not difficult. If you can graph a thing and if you know how to fraction, you're fine. Okay? So, with that, hi.
This way you're talking about triangles at the end of the video yesterday?
Yes. Hi.
Why is Kermit keeping over paper?
Have you ever opened your textbook?
That's pretty
Yes.
creepy.
Is there always something there?
Your textbook at the beginning of section 4.1 has a little story problem, and there's a little picture of Kermit in the corner because it's something with Kermit the Frog. I don't know. I just screenshot this out of the book.
Okay.
So in this case, we have Kermit's head. Right? Actually, because it's purple up here, it's more like, I don't know, Barney's like pedo cousin or something. I don't know.
No, Bonnie was already
Yeah. So, we kind of talked review yesterday. The review was, do you remember good old SOHCAHTOA? Okay? You have 6 trig functions. 3 of them you're probably familiar with. First of all, you have to identify what is opposite, adjacent, and hypotenuse. This only works for right triangles. That's why this section is called right triangle trig. Everything that we're about to do, you cannot do if it's not a right triangle. Okay? So you identify your angle. We call it theta. Theta is little, it's not empty set. You just move the line there. Okay? Another one of those Greek letters. Okay? Theta is the angle. Whatever is across from it naturally is opposite. The way that I always remembered it was, it's the stick you shove in the gator's mouth so he doesn't bite your leg. Okay? It literally, here's angle. Ah, no. Or the bone that Luke shoves in the Rancor's mouth. Okay? Return of the Jedi, watch it. Uncultured swine. So, opposite is across from, that's cool. Opposite is across from it. Adjacent, well, you know the word adjacent. Adjacent means right next to. So adjacent is the leg, specifically the leg right next to it. Hypotenuse is always across from your 90-degree angle. Okay, always across from the 90. Also, there was something called a triangle proportionality theorem back in geometry that says the biggest leg or the biggest side is always across from the biggest angle. The smallest side is always across from the smallest angle. So I know that the hypotenuse has to be the biggest side because it's across from the 90. Why do I know hypotenuse has to be the biggest? Why do I know 90 has to be the biggest?
Every triangle has a 180. If one angle is 90, then that's
Okay. Right triangles have 90-degree angles. If I have a 90-degree angle and then something past 90, I have broken triangle. Okay? So, there's your definitions. Once you have those, SOHCAHTOA. You got to put a little phlegm in there, though. SOHCAHTOA. What it means is the sine of theta is the opposite over the hypotenuse. The cosine of theta is the adjacent over the hypotenuse. The tangent of theta is opposite over adjacent. Okay? So those are the ones that you probably, I think it's in our Algebra 1 curriculum at the end of the book. In this particular textbook. You definitely should have beat on it in geometry. What you probably didn't get were their goofy, were their goofy bass-ackwards cousins from Alabama. The reciprocal functions. The reciprocal of sine is called cosecant. And it's just hypotenuse over opposite.
CSC.
Yes, cosecant. If you haven't seen it before, cosecant. Oh, also, y'all, sine, cosine, tangent. The kid that says, I'm going to do cos 42. Oh, we fighting. We fighting. Don't say, what's sin 30 again? No. No. Bad. Just tangent. Tangent. Secant is a reciprocal of cosine. And the cotangent is adjacent over what? All right.
So if I say cot, then I'm in trouble.
Yep.
But then like they look like words you know, like set. That's what it does.
Okay. Those are the 6 trig functions. Know them well. It is just a ratio. Just like, pi isn't magical number. Pi is technically the ratio of circumference over diameter of any circle. You might have done that back in elementary school or maybe middle school, where you get something round and you wrap the string around it, then you measure the string, then you measure the diameter. You do that for like 20 objects. Do circumference divided by diameter for all of them, and then you average them out, and lo and behold, about 3.14. No? Maybe? Like 2 of you remember this? Okay. So, I had a Jimmy Dean sausage and egg croissant.
This is what I had today.
Because I can shove it in the microwave and I can eat it on the drive to school. So, crankshaft. He said something delayed and absolutely random, so I reciprocated. So, I know. So, find the 6 trig values of a triangle. This should look familiar to you because it's one of our Pythagorean triples. If you don't know the Pythagorean triples, they are integer numbers that satisfy Pythagorean theorem. The 3 most common are 3, 4, 5, 5, 12, 13, and 8, 15, 17. Those are the most common Pythagorean triples. You're going to see them an awful lot. Not just those numbers themselves, but they're used in multiples to create other triangles. So, like, a mathematician might run along and say something like, this is 39, this is 65, what's this? Well, if you recognize that 13 times 5, 13 times 3, oh wait, 3, 5. It's a 3, 4, 5 triangle. So I'll just take 13 times 4. Okay? So they'll use multiples. But this is a 8, 15, 17 Pythagorean triple triangle. From this angle, label stuff. What is 17? 8. 15. And then use your definitions of our 6 trig functions to say the sine of theta is opposite over hypotenuse. The cosine of theta is adjacent over hypotenuse. The tangent of theta is opposite over adjacent. And then their bass-backwards cousins, cosecant is going to be 17 over 8. Secant is going to be 17 over 15. And cotangent is going to be 15 over 8. Do not take them to decimal land. Don't you dare round anything. You leave it as a fraction, even if it involves radicals. Okay? Because if you don't, you will lose part of the triangle. Like, you will just poof. You ever seen that thing with, it's like a whole bunch of different blocks, and if I rearrange the blocks, the triangle turns into like this. There's that tiny little corner missing. It's a pretty famous problem, like a thought puzzle. You're going to be missing part of it if you go to decimal town. So, do you know what Socatois is? We'll do 1A because it's a really good podcast. NPR is the closest that we'll get to a factual non-biased in this country.
What are you talking about? Joke.
I have enough in my car. Do you want that instead?
I'm actually thinking about the pool noodle.
It's a joke.
Remember, this is like talk to each other time. Okay, should be fairly quick. From theta, identify you have opposite, adjacent, hypotenuse. Jam things in. Sine, opposite over hypotenuse. Cosine, adjacent over hypotenuse. Tangent, opposite over adjacent. And then their reciprocal functions are 13 fifths, 13 twelfths, and 12 fifths. Ta-da! Cross out 1b. Y'all should know this stuff. Unless you need the practice, then leave 1b, come back to it later. Okay. Use one trig ratio to find the others. If I know one of them, that good old Pythagorean is going to help me find the rest. I'm going to start by finding I'm just going to draw a generic triangle. It might not be to scale. That's okay. I'm going to shove theta in the corner. I'm going to make sure it's a right triangle. And then if I just said that cosine is 2 fifths, where can I put the 2 and the 5? Adjacent hypotenuse, right? So 2 goes at adjacent, 5 goes at hypotenuse. How do I find the missing link? Good old Pythagorean. Now, most of us are probably going to remember this, but that involves reinventing the wheel sometimes. The way that I always told my geometry classes was the hypotenuse is square root of leg squared plus leg squared. A leg was the square root of hypotenuse squared minus leg squared, which is just this rearranged, right? No, you do it however you're going to do it. But since we're well past geometry, what?
I just needed the second.
Yeah, I was on the second one. I'm using.
Okay. Basically, if I know Pythagorean theorem well enough, I can just say 25 minus 4 is 21, square root of 21. Like, I don't have to write it out. I don't have to write it out and solve, because I've been working with Pythagorean theorem for, I don't know, about 4 years, right? Like, when was the first time you saw Pythagorean theorem? Middle school, easily. It should have been, I think it's a 7th grade standard. Okay. This also means whenever I am finding a missing side of my triangle, make sure that you have a simplified radical. Now can I erase it? So now, sine, cosine, tangent, the cosecant, secant. All right. So we already knew to begin with that this was 2/5. So I know that secant, its reciprocal, is 5/2. Then identify opposite, adjacent, hypotenuse, and get going. Sine is opposite over hypotenuse. Square root of 21 over 5. Tangent is opposite over adjacent. Square root of 21 over 2. But when you get to cosecant and cotangent, you have to make sure that you rationalize. It is not difficult. If you recognize that 5 over square root of 21, you're just going to multiply by square root of 21, it's not hard to turn this into 5 root of 21 over 21. Okay? It's not hard to flip this into 2 the radical over the radicand. Okay?
You have to have the after everything you have to have that circle.
Theta?
Yeah.
That's the name of the angle, and yes, it is. Just like when I say f of x equals stuff, you can't just say f is stuff, right? I'm saying the cosine, that is my function, of the angle theta is this.
So you have to.
Yes, you do. Okay. So, you can't say wait when it's already in my hand. Do it again.
Go so fast.
Because this is supposed to be the 3rd or 4th year you've done it.
It's like the second.
Okay.
For these, since I know we always switch around the radical, but then do I have to
You don't have to
use
flip and
okay.
rationalize that. You can just say square root of 5. Yeah. That's actually a really good point. Okay. Before we go writing anything, do you at least have your triangle set up correctly?
Yep.
Tangents opposite over adjacent. Put your 1 and 2 in the respective spots. Pythagorean theorem gets you your hypotenuse. Once I've got the hypotenuse, sine is opposite over hypotenuse. That's 1 over square root of 5, but you need to rationalize it. Square root of 5 over 5. 2 over square root of 5 and rationalize. 1 over 2 was given to us. Okay. And Claire asked the question, do I have to flip this and then rationalize it? Right? Because then you'll have 5 over square root of 5 times square root of 5 times square root of 5. So now I have 5 root of 5 over 5 by 5, and then 5, wait, no, that's just actually a 5, but then that cancels, and then I just have square root of... Boy, that was a lot of unnecessary work if I would have just said hypotenuse over opposite. Square root of 5 over 1. Okay? And then square root of 5 over 2. And then 2 over 1. Okay? So when kids come up into my Algebra 2, and I kind of get on them about writing things in simplified radical answers, you've heard me rant about that in here, especially at the beginning of the semester. The reason is you should have been doing it this whole time. And I know that you weren't. Okay. So I put this up yesterday, and some of us got a little sketchy about it. So first off, how much room do you got? Yeah, you got some room under this big box there. If you don't know where these ratios come from, if I have a 45, 45, 90 triangle, remember those little marks? Congruent. What's it called when you have a triangle that has two congruent legs? Isosceles. Okay. And since this is 90, that means the other two angles must also equal 90 because triangle sum theorem. And since the legs are the same, that means the angles have to be the same. It's called base angles theorem. Okay. So those both have to be congruent as well. So I take the 90 divided by 2 and get 45 each. Well, what if I have no freaking clue what the sides are? I can put x here, right? So if that's x, then this is x. Then that means this side is the square root of x squared plus x squared, which is the square root of 2x squared, which is x square root of 2. And that's where the ratios for this come. 1, 1, square root of 2. If it's a 45, 45, 90. 1, 1, square root of 2. Now it is a ratio. So technically, it's x, x, x squared root of 2. Because if I know that it's a 45, 45, 90 triangle, if I know it's an isosceles right triangle, then I know one of the legs, I know all of the legs. Say I had, and this was, I don't know, 18. I can find the other two now, right? How do I go from hypotenuse to leg? What do I do to go from square root of 2 to 1? What do I go to square root of 2x to x? What disappeared? I divided by it. So take 18 divided by square root of 2. Getting, okay, and then isosceles, so please tell me this is familiar. Y'all are freaking me out. Like, genuinely worrying me. Okay. Oh boy.
I have no idea.
All right. Did everyone in here have geometry during the shutdown?
Yeah. Except for maybe, you know. We had it in the beginning of sophomore year. First semester sophomore year, but I had the grades that didn't go well. It didn't
Okay.
go well.
All right.
I did learn this.
Okay. Then, what I would like you to write next to it, my old geometry cheaters, if I'm in a 45, 45, 90 triangle, if I'm going from a leg to a hypotenuse, I multiply by square root of 2. If I'm going from a hypotenuse to a leg, I divide by square root of 2. And I'll write it out for 30, 60, 90s as well. But do you see where the square root of 2 came from? Like it's just Pythagorean on variables. Okay? May I? Well, let's find out. What if I take if I have an equilateral triangle, all of my sides are the same. So, my triangle sum theorem says all triangles have an interior angle measure of 180 degrees. All the sides are the same, all the angles are the same. Take 180 divided by 3 and get 60, 60, and 60. But what if I, instead of having that 60 up there, chopped it square in half? Do y'all remember what it's called if I cut this angle in half? Bisect. Bi, to, sect, cut, bisect. Okay, so I have cut the angle in half. It is not 60 anymore. It is now 30 and 30. What do I call it when I cut a side of the triangle in half? If this line cuts that side in half, any line contained between 2 points is called a segment. Segment bisector. Specifically, because this one is perpendicular, it's called a perpendicular bisector. Seriously, take your ACT in February. After this class, use the couple of weeks after this semester ends to do review on geometry. Then take your ACT, and by the powers of PreCalc and geometry combined, you shall be awesomeness. Okay? We'll try to schedule after school review sessions. Okay? I know we got a lot of juniors in here. So we said all the sides are the same, and if we don't know what the sides are, normally we would call them x, right? Because I know what's coming, and I don't want to deal with fractions, what if I called it 2x instead? What happens when I bisect the segment? What is each one of these? 1x. And then do Pythagorean again to get that middle piece. It's the square root of hypotenuse squared minus leg squared. X squared of 3. Which is where my ratios come from. In a 30, 60, 90 triangle, across from the 30 is the smallest of the 3, 1. Across from the 60 is the middle of the 3, square root of 3. Across from the 90 is the biggest of the 3, 2. 1 square root of 3, 2. Okay. Now, what we used to call these was my short leg, long leg hypotenuse. If I'm going from hypotenuse to short, what do I do? To go from the hypotenuse to the short, what do I do? I went from 2 to 1. Divide by 2. If I'm going from the hypotenuse to the long leg, well, I would divide by 2, and I would multiply by square root of 3. So we'd say times square root of 3 over 2. What? Oh, I can't talk and write at the same time. Yes. Okay. If I'm going to go from short leg to hypotenuse, I'll multiply by 2. Short leg to long leg, I'll multiply by square root of 3. If I'm going from long leg to short leg, I will divide by square root of 3. And if I'm going from long leg to hypotenuse, I will multiply by 2 over square root of 3. Well, you don't need it. If you just have the purple triangle, you're good to go. The white part was a cheater shortcut if you don't have those special ratios memorized. I also have holy sheets for all of geometry, if you want those. So, that's where all of this stuff comes from. I kid you not, almost everything from today through section 4.7 is built off of these two triangles. Just like everything in polynomials was built off of quadratics. Just like in geometry, you spent so much time on triangles because your parallelograms and other polygons were built off of triangles. The entire branch of mathematics, trigonometry, is built off of these two triangles. If I have 1 square root of 3, 2, and if I have 1 square root of 2, I can now fill these in a 45, 45, 90, going from a 45-degree angle. So start here, look at what's opposite, adjacent, and hypotenuse. What is sine? 1 over square root of 2. Rationalize. Square root of 2 over 2. The cosine is also 1 over square root of 2 because isosceles. So, tangent. Opposite over adjacent, 1. They're reciprocals. So now, cosecant is hypotenuse over opposite. Square root of 2, right? Square root of 2 over 1. Same here. And the reciprocal of 1 is still just 1. when I go to 30 degrees. Looking from this, I have opposite, adjacent, hypotenuse. Fill it in. You do it. Fill it in. Fill in that chart. Well, that's why we include SOHCAHTOA as that mnemonic device.
I have it saved from yesterday.
Oh, cool. Okay. Over to. Okay. Now, if I know all that stuff from 30, I flip it on its side from a different perspective, and I'll get all that stuff about 60. And you're going to see a pattern. If I look from 60 now this is opposite, this is adjacent, still hypotenuse. From 60, we've got opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, and their reciprocals. What do you notice? Same numbers on repeat. That's going to be a theme for the next couple weeks. The same numbers on repeat. There's a reason that when you hit trig, you don't get the unit circle. You don't get this chart. You don't get notes for that stuff because it's the same thing over and over and over and over, just in different flavors. See, it's called cosine for a reason. Because 60 is the complement of 30. Cosine is the complement of the sine. So it should make sense, if you noticed it, that the sine of one is the cosine of the other. The cosine of one is the sine of the other. If I know these two, I reciprocate, and both of these are 2's. If I know these two, I reciprocate. Both of these are 2 squared to 3 over 3's. If I know one of them, then its reciprocal for the other angle is the same thing. Then you find the reciprocal of this to fill out the other two. If I know these 3 measures, I know the other 9. Okay? And it all came from that. Y'all got to know them. Flashcard, Kahoot, Quizlet. I don't care how you do it. You got to know those. Okay? The next few weeks will be annoying if you don't know those. You got to know them. Okay? All right. Now, everyone got a calculator on hand? Y'all find sine, cosine, tangent buttons. Okay. Hey, we just did this whole chart. We did this chart for special right triangles. Go ahead, type it in. What is the sine of 30?
Is it negative? Like sine to the negative?
Those are arc functions. We're getting there.
Oh, okay.
We're getting there. What's the sine of 30? No, it is not. We just had it on a chart, didn't we? What was the sine of 30?
That's dumb.
A half. Try again. What's the sine of 30? A half.
That's not there.
Wait, what?
What? I'm listening. Why does it have
It's lying to me. Everyone take a look at the top line of your screen. What mode are you in? Radians. The calculator defaults to radians. So if you're one of those kids that doesn't know how to, I don't know, clear lists and stuff, and you just completely reset it every time, it's going to default back to radians every time. Radians is something that we don't even know what it is. It's like if I started saying, I'm going to charge for my Pop-Tarts in rupees. Okay?
I thought he said roofies at first. I was like, what?
No. Okay?
Game? There's like 20. Well, yeah, but the one that I played was fire.
I was talking about the Indian form of currency, but yes, also rupees in Legend of Zelda. If you would please go to mode. And we're going to switch that from radians over to degrees. I will tell you, your calculator does not need to be in radians for the vast majority of what we're going to do, even though from 4.2 onward, we're going to work almost exclusively in radians. Okay? Now, if my calculator has that ratio stored in there, it's because the sine of 30 is always going to be a half. Because no matter what the size of the triangle, from 30 degrees, 256 over 512 is 1/2. It's a ratio. A ratio is a comparison. If I know that for every 2 girls in the gym dancing at homecoming, there's like 0.8 guys, I can use that ratio to extrapolate out to what if I know that there's 38 girls in there. Okay? So if that ratio is a known quantity for every angle, what if I were to, I don't know, program it into my calculator? So that's how we start solving things. From 42 degrees, what 2 things do I have? Opposite, adjacent, or hypotenuse? I have a hypotenuse and an adjacent. Which trig function has those 2 things? Cosine. So the cosine of 42 degrees is opposite over opposite over hypotenuse. So if the cosine of 42 is a known quantity that is in my calculator, cross multiply and solve. X times 1 is just x. 18 times the cosine of 42. This is why I know that your geometry teachers don't show you to do this. 18 cosine of 42. That is the expression answer. That is the correct answer. Now give me the decimal approximation with it. To the thousandths, I don't care what the directions say anywhere in this book. We will go thousandths. Okay? So you look at what things do I have, what ratio does that compare to, use that button to set up problem. Also, go back to old school algebra half. I literally did this 2 days ago with algebra half. You know, with ratios, if maybe that was 18 over x instead, you just multiply the two that line up, divide by the one that doesn't, right? What if this was 18 and this was x? No. That's the arc function, and that has bothered me since I first learned it in 1999.
So these aren't reciprocal functions.
No, they are not. They are arc functions.
Makes no sense.
It's dumb, isn't it? You're supposed to do 1 over cosine to do the cosecant.
Well, that bothers me.
It bothers me. It's bothered me for 22 years.
I don't know. Never mind.
So, the cosine of 42 now is 18 over x. So instead of writing out x cosine of 42 and then dividing, you Jesus fish. Jesus fish. Alpha. The whole alpha and omega thing, Greek alphabet, beginning and end. How many Karens do you see driving around with a Jesus fish on the back of their minivan? Right? Okay. You multiply the two that line up, divide by the one that doesn't. Didn't you take 18 times 1 and then divide by the cosine of 42? It's just a shortcut to ratios. Jesus fish. Now, sometimes Jesus fish can turn upside down on its head. That's okay. So in our original, we had x over 18. Didn't we still multiply the two that line up, divide by the one that doesn't? It's just, it just tipped on its side. Huh? Poor Guppy, you know, floop. You must now flush Jesus fish. Sorry. You know the best way to put it out of its misery? Like, so many people will just leave it in the live well all the way until the scale house, and then they're like cutting open a fish that's flopping around. That's so dumb. Just grab it, crack its head on something heavy. Like,
I do that sometimes with Sunny slapping. People with Sunny and Skill, they
okay, that's cruel.
It was really cool. I did not participate. I just judged.
All right, let's do the thing. Find your x's. We'll figure out why later.
Just straight up. Like, all right. What if I said on the test? I just said it's right.
Good thing the directions will be solve for x.
Will we still use cosine or will we use something else?
Oh, you might use sine, you might use cosine, tangent. You're going to use one of them. Now, a good chunk of you are going to start really tripping out because, oh no, they drew the triangle at a different angle.
Yeah. Oh, why would they do that?
Because, watch this, ready?
No.
If you don't like that one, ready for this, ready? Just turn the paper until it looks like you want it.
Then the numbers are upside down. Then you look
I don't
96. Oh my god.
I hear that leads. Oh.
It reminds me of like a painting on a wall.
Finish the statement, please.
Your hair looks nice. I encourage you to write your answer as first a simplified expression, like we had 18 cosine of 42, and then write the decimal approximation. Yeah?
Oh, okay.
Both.
Is this first one not sine 53 divided by 13?
Oh, yeah, it is. I was too busy listening to ping and pong back there, not shutting up.
No, 53 divided by.
What? Multiply the two that line up, divide by the one that doesn't. And I'm going to assume that you can press buttons correctly. In fact, for kind of the rest of this unit, I'm going to rely on you to press the buttons correctly. I don't want to press the buttons. Right angle is always across from the hypotenuse. Did I say co? All right.
Why did you do that?
Because I'm distracted.
I didn't do anything. You guys better clean your act up. Hey.
There you go.
He has to get 5.
I will not tolerate this kind of behavior. Wait, so why did you get 2?
So we use the other.
Because I did it over there, and then you kept blabbing, and all I heard was, and I didn't again.
Good job.
Oh. So it was my fault. Got it.
Blah, 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 same thing, but words. Okay. Now, y'all seen a surveyor working out by a construction site? The dude with the little tripod and the little periscope that's checking out the gradients and making sure that everything is level. Do you know that they are doing basic right triangle trig that whole time? It's not difficult. y'all ever seen a documentary on military snipers? They have to know a ridiculous amount of math.
Yes.
And that's why their spotter is calling stuff out, and they are writing down calculations. They have to bring a calculator and a calculation book with them to make the correct shot. Because at a certain distance, even the curvature of the Earth comes into play. Yes.
Most of the time, you just type into an app nowadays, though. And like a little computer. I would go to school. I know because we do.
But you better know it, because what happens if your calculator breaks? Well, I guess that general got away.
That's true.
So,
Oh, what's the movie called? The American Sniper. Have you seen that?
yeah, I'm not a fan of deitizing someone who... No, let's do this. Blah, blah, blah. Runner has thing. They're going to go that way, then they're going to go that way. What if they had just gone straight to the finish line? How far would it have been? Look, it's the exact same thing, right? From the 63, what do I got? Opposite, adjacent, or hypotenuse? Opposite and hypotenuse. So I'll say that the sine of 63 is opposite over hypotenuse. Multiply the two that line up. Divide by the one that doesn't. 200 over sine of 63. And since the sine of 63 is a boot square root of 3 over 2, a boot, I would say that that's about 400 over the square root of 3 approximately, but get it for real, okay? So we're going to start with basic right triangle trig. Tomorrow, more right triangle trig. If we do not get through the rest of 4.1 tomorrow, I will be incredibly disappointed. This is normally a day and a half lesson. I know that y'all got hosed. We're trying to make up for it now. I got hosed in every area code. No. Hosed. Hosed. Yeah.